So, yeah, there are three ways to solve a system: substitution, elimination, and graphing. Graphing is just that, graphing. Substitution, plugging one into another. Elimination, you're trying to get opposites. When it comes to a word problem, we focus on substitution and elimination, two algebraic methods. It's not because we don't like graphing, we just prefer not to graph if we don't have to. So when we solve a word problem, we've done word problems enough to know that the first step is to read the problem. Since it's a system, you're going to have two unknowns. Identify the unknowns and give variables. Set up the equations, solve the equations, and check to make sure that they make sense. No one's saying that you have to work it out and show that, okay, these work or these make sense, but you should at least make absolutely certain that the answers that you get are relatively valid. So with that, I mean, the simplest way to go through working the word problem is to actually do it. When you take your unit test next week, so again, your unit test will take place next week on Monday. Part of it will be in class, part of it you'll have that day and the next day to do the at-home portion and submit it. So that's pretty much how that will work. Nonetheless, with word problems, read, figure out what you're missing, set up the equation, solve it. Pretty straightforward with what you need to do. So let's kick things off with example number 1. You and some friends are thinking of renting a party bus for after graduation. The total cost of the party bus is the rental fee plus the charge per mile. Main Street Buses charges $40 rental fee and $2 per mile. Exquisite Lines, $20 rental fee, $3 per mile. How many miles must you go in order for both companies to be the same? And how much is that total cost? So again, first order of business is for you to read it, if anything, so that you can see the words and start to interpret what's going on. So that's your first order of business. So now we start trying to solve it. So the total cost of the party bus is the rental fee plus the charge per mile. So that's one thing, key piece of information. Total equals the rental fee plus cost per mile. So let's start going through the problem and look at what's missing. So rental fee, they told us rental fees. So it's not like we're missing that. Charge per mile, they told us how much it costs per mile. What we don't know is the number of miles and the total cost. So those are the two things we don't know. We don't know how much they paid total, and we don't know how many miles they went. So those are the variables we need to assign. So X, number of miles, Y, total cost. Any questions so far? Again, primarily the hardest part about a word problem is that you have to read it. You have to read it, you have to interpret it. So now, keep going through the problem. So now they give you two different scenarios. They talk about Main Street buses, and they talk about exquisite lines. So since they're giving you two different companies, that's what you're going to use to set up your equation. Each company will get its own equation. And remember, they told you this to help you set up the equation. So Main Street buses, $40 rental fee plus $2 per mile. So that's y equals 40 plus 2 times the number of miles. For exquisite lines, we use a similar setup. $20 rental fee plus $3 per mile. 20 plus 3x. So you've got your equations. Any places where you're stuck before we move to the solving stage? All right, time to solve it. So, we have our system. We can solve it using substitution, or we can solve it using elimination. Which one you choose, that's up to you. Word problems, you are not told how to solve them. But I will give you some pointers of what you should do. So remember, you have substitution, and you have elimination. So which one you should use depends on how the problem is set up. So substitution you should use when you have x equals something or y equals something, because you already have a problem set up. Elimination is when you have your variables on both variables on one side. So for example, 3x plus 4y equals 12. Both of your variables are on the left-hand side. So that's a perfect setup for elimination. So if you see this problem, you've got y equals and y equals. This is a perfect opportunity to use substitution. So this is a substitution problem. So let's make that happen. Y equals 40 plus 2x. Y equals 20 plus 3x. Since both of them are equal to y, you can set them both equal to each other. So y equals, you can take the two equations instead of equal to each other. Then you solve it out. Subtract 2x on both sides. 40 equals 20 plus x. Subtract 20. So x is the number of miles. So you're going to have to travel 20 miles. It's one part of your answer. Questions, comments, concerns before we finish the problem? All right. Figure out how many miles we have to go. Now we got to figure out the total cost. Total cost is y. You already know x. Pick the equation. Plug it in. Does it matter which one you pick? No. So 2 times 20 is 40. 40 plus 40 is 80. So it's going to cost $80 to rent this bus. If I want to go 20 miles, it's going to cost $80. This bus is definitely not in Chicago. No way would a party bus cost $80. But that's that for example 1. Question, example 1. Steve, I know you be asking, you have any questions? You go. You straight? I just set it up. I set it up that way because that's how they worded it in the problem. If you did 40 plus 2x equals y, it wouldn't make a difference. Any other questions? We'll go to example 2. Again, we're still solving systems. The only difference is now you are setting up the problem. All right, so example 2. So Steph Curry scored 37 points in the game the other night, shooting 2-point jump shots and his famous 3-point baskets. He made 4 more 3-point shots than 2-pointers. How many of each shot did he make? So again, first step, read the problem. So just because he's a part of my top 5, so again, just in case anyone wanted to know, these are my top 5 favorite players of all time. If you don't like my list, too bad. This is my list, point blank, period. That's my top 5 list. If you don't like it, too bad. If you don't like the fact that I put LeBron 4th, too bad. Anyway. So Steph Curry scored 37 points, shooting 2-pointers and 3-pointers. He made 4 more 3-pointers then 2 pointers. How much of each shot did he make? So let me give you a minute to wax. Right. So what don't I know? What am I missing? No. The number of 2 pointers made. And I don't know the number of 3 pointers made. All right, so there's X, there's Y. Why did I make 2 pointers X? Because I felt like it. I could have switched them around if I wanted to. So there it is. Now we got to set up an equation. So I'm actually going to start with this one that I just put in green. He made 4 more 3-point shots than 2 pointers. He made 4 more 3-point shots than 2 pointers. He made 4 more 3-point shots than 2 pointers. So 4 more is an indication of what operation? If you have 4 more of something, am I adding, subtracting, multiplying, dividing, kicking, screaming? I know I have 4. More than means something. That's addition. So 4 more 3-point shots than 2 pointers. So my 2 pointers are X. I made 4 more 3-point shots than 2-point shots. That means my 3 pointers would be X plus 4. So X, Y, do that. So one of your equations is Y equals X plus 4. Any questions on where the first equation came from? Well, let's see what happens. So let's see, suppose we switch these. You have Y plus 4 equals X. So remember, Y is the number of 3 pointers, and X is the number of 2 pointers. So, and that means for every 1 3-point shot you take, your 2 pointers would be 5. So you shot 4 more 2 pointers than 3 pointers. Is that what the problem said? So that's an easy way for you to check to see if what you wrote is right, though. That's an easy way for you to check to see if you were right. Now, if it's wrong, or if it doesn't match up, that should let you know, okay, I gotta do it the other way around. That's an easy way to check this. So there's the first equation. Second equation. He scored 37 points. How much is a 2-point shot? Okay. Hopefully it shouldn't take that long to know that to figure that part out. How much is a 2-point shot? 2 points. 2-point shot is worth 2 points. How much is a 3-pointer? 3-point shot. You'd be surprised how many people will get the easiest stuff wrong. We scored 37 altogether. So the only thing we're not counting here are free throws. So there's your 2 equations. Take the information of the problem, synthesize it into the 2 mathematical equations you need, and then you go to work with it. And now we're going to go to work with it. So now we have our problem. We have to think to ourselves, am I going to do substitution or elimination? Notice that you have y equals something. Y equals something makes it very, very easy to decide what to do. Y equals use substitution. Yeah, anytime you have a variable already by itself, use substitution. It's the easiest way out. It's the easiest way out of the problem. So, let's go ahead and solve it. So substitution, we're plugging one into the other. So we're going to take x plus 4, plug it in for y. Two x, 3 times x plus 4 equals 37. And this is the way you want the equation to be set up, because this makes it a lot easier to solve out. This makes it a lot easier to solve out. Distribute. 2x, 3x, 12, 37. Two x and 3x is 5x. Subtract 12. 5x equals 25. 5x equals 25, so x equals 5. So we made 5 2-point baskets. 5 2-point baskets. Which means for your 3-pointers, if you made 4 more 3-pointers, you had 9 3-pointers. So 9 3-point baskets. Simple enough. Questions on example 2? We'll do one more example, and then the other 3 examples will be saved for Wednesday. All right, so take a quick minute, read example 3, start setting it up. I'll kept the screen. One of those good old length and width and perimeter problems, which shows up just about everywhere without fail. Never fails, it almost always shows up. Another few moments and then we're going to knock this one on out. So let's knock this one on out. The length of a rectangle is 3 times the width. The perimeter is 48 units. Find the length and the width. So anytime you are dealing with a perimeter problem, here's your rectangle, there's your length, there's your width. Perimeter is 2 times the length plus 2 times the width. 2 times the length and 2 times the width. So they're telling you in the problem, find the length and the width. So length, x, width, y. Okay, use x and y because those are the most common variables. You don't want to use x and y? Be my guest. Done. So let's start setting it up. The length of a rectangle is 3 times the width. So length is x is equals 3 times the width. So the first equation literally set up itself. First equation literally set up itself. The perimeter is 48 units. So perimeter 48 units. Okay. P is 48. 2 times the length is x. 2 times the width, 2x plus 2y. There's your equation. There's your system. Again, some of doing the word problem is not trying to make the problem harder than what it is. Not trying to overthink the problem. There's a lot of people who do that. And that's okay, because I'm guilty of it as well. Overthinking, overanalyzing the problem. Sometimes it's straightforward. You just need to set it up and solve it. Any questions before we work this on out? Let's go ahead and knock it out. X equals, so this is a substitution problem. Take 3y, plug it in for x. 2 times 3y plus 2y. 2 times 3 is 6. 6 and 2 is 8. Divide by 8, you get 6. So y is equal to 6. So your width is 6 units. So your width is 6. So that means the length should be very simple then. The length is 3 times the width. Length is equal to 3 times the width. X equals 3y. You know what y is equal to. $18. So your length is 18. Trust me, you are bound to get a problem that is pretty straightforward. You're bound to get one. So, if you get it, take advantage of it. Any questions, example 3, before we close on up? We'll work 4, 5, and 6 on Wednesday. All right. No complaints from the head.